All right, here we go. 2-6 video. Ratios, rates, and conversions. After this lesson, I'll be able to find ratios and rates, convert units and rates. Okay, so you got a lot of fraction work here. So here we go. 2 Olympic athletes can run the race in the time shown below. Who is the faster runner? How do you know? So athlete A runs 800 meters in 116 seconds. Athlete B runs 1,500 meters in 338 seconds. So if we can find out how far they go per second, then we can know who's going faster. So if we go to athlete A, he's running 800 meters in 116 seconds. Well, 800 meters divided by 116 seconds would tell me that it's 6.89-ish meters per second. Okay? So in 1 second, he goes about 7 meters. Athlete B runs 1,500 meters in 338 seconds. So if I take my meters and divide it by seconds, I'll know how far he goes per second. So 1,500 meters divided by 338 seconds tells me he goes 4.43 meters per second. So athlete A is going more meters each second, therefore he is going faster. All right? Very nice, thank you. A ratio compares two numbers by division. The ratio of two numbers, A and B, where B is not equal to 0, can be written 3 different ways. Well, we can write it as a fraction, A over B. We could also write it using a colon, A is to B. Or we could write it with the word to, so A to B. So for every A units of one quantity, you have B units of the other quantity. We can also think of ratio as a multiplicative relationship. For example, if the ratio of the number of boys to the number of girls in a class is 2 to 1, then the number of boys is 2 times or twice the number of girls. So if the ratio is 2 to 1 and there's 10 girls, that makes there 20 boys, 2 times as many. A ratio that compares quantities measured in different units is called a rate. Rate with a denominator of 1 unit is called a unit rate, unit meaning 1. In the solver problem, we expressed each athlete's speed as the number of meters traveled per 1 second. So that's an example of a unit rate. Okay? We can write ratios and find unit rates to compare quantities. We can also convert units and rates to solve problems. So here we go with some examples. You are shopping for t-shirts. Which store offers the best deal? Well, store A has 25 t-shirts $25 for 2 t-shirts. If we can write each price as a ratio, then find the unit rate, we'll know how much it costs per t-shirt. And then we can find out which deal is the best. So $25 for 2 t-shirts, 25 divided by 2 t-shirts makes $12.50 per shirt. All right, there's my unit rate. Per 1 shirt, it's $12.50. Store B is $45 for 4 shirts. So 45 divided by 4 makes $11.25 per shirt. And store C is $30 for 3 shirts. So that's obviously $10 per shirt. So the best deal out of $12.50 per shirt, $11.25 per shirt, and $10 per shirt is obviously store C, $10 per shirt. To convert from one unit to another, such as feet to inches, multiply the original unit by a conversion factor that produces the desired unit. A conversion factor is a ratio of 2 equivalent measures in different units. A conversion factor is always equal to 1, such as 1 foot is to 12 inches, or 60 seconds is to 1 minute. Okay, and you can flip those over as needed, and you'll see what I mean here in a second. Okay, what is the given amount converted to the given unit? So we're trying to convert 330 minutes into hours. So I'm going to need a conversion factor. So 330 minutes into hours, what I want to be able to do is eliminate the minutes. So if I can create a conversion factor that'll give me hours and get rid of my minutes, then I would be left with only hours. So 1 hour is to 60 minutes. So there's my conversion factor. These are the same thing. 1 hour and 60 minutes are the same thing. So this factor here is equal to 1. But what you see here is, if I just make it a nice fraction, it might be easier to see. A top unit here would cancel a bottom unit here as long as they're the same. So minutes on the top cancels minutes on the bottom, and the only unit you're left with is hours. So I'm converting to hours. That's good. That's the only thing I'm left with. Now it's just a fraction problem. Go across the top, multiply. You'd wind up with 330 hours. And on the bottom, you just have numbers now. So 1 times 60 is just 60. And now if you just simply divide that, 330 divided by 60, you'd get 5.5 hours. All right, so pretty easy to do once you come up with those conversion factors. So 15 kilograms converted to grams. Well, I want to get rid of the kilograms, so I'm going to need a kilograms on the bottom here. I want to be left with grams, so my conversion factor has to deal with grams and kilograms, with kilograms on the bottom, so he will eliminate those kilograms on the top. Because when at the end, all I want to be left with is the grams. So 15 kilograms over 1 times 1,000 grams over 1 kilogram. The kilograms will cancel, and all I'll be left with is grams. So 15 times 1,000 is 15,000 grams over 1. Well, 15 over 1 is just 15,000 grams. 5 foot 3 inches into inches. Well, I don't want to convert the 3 inches part. That's already inches. So I don't care about that part. I care about the 5 feet. So I got to be able to convert 5 feet into inches. Well, 5 feet is 12 inches in 1 foot. So I want to be able to put the foot on the bottom to cancel out this foot here. So what happens is your 5 feet will cancel your 5 feet, and you'll wind up with 60 inches out of your 5 feet plus 3 more inches. All right, you didn't have to convert that part. That was already in inches, so that was good to go. 60 inches plus 3 inches makes 63 inches. The CN Tower in Toronto, Canada is about 1,815 feet tall, 1,815 feet tall. About how many meters is the tower? And they give me a conversion factor of 1 meter is about 3.28 feet. So if I use my conversion factors, 1815 feet times 1 meter over 3.28 feet. Notice I put the feet here on the bottom so it would cancel this feet, which is really on the top. All right, you can always make this into a fraction by putting it over 1. It might be easier to see that this is in fact on the top. So you need this foot on the bottom so that they cancel out, so that you're only left with meters because you want to know in how many meters it is. The feet will cancel the feet, go across the top and multiply. You'll wind up with 1815 meters. And on the bottom, all you have is numbers, 3.28. So 1815 divided by 3.28 is about 553 meters. Monetary exchange rates change from day to day. On a particular day, the exchange rate for dollars to euros was about $1 is about 0.63 euros. About how many euros would you get for $325 on that day? Well, if I use my conversion factors, I know that I want to take $325, convert it to euros. So euros is going to have to be on the top. Dollars is going to have to be on the bottom so that it cancels out with that other dollars. Dollars and dollars are canceled. Go across the top. 3.25 times 0.63 euros would leave me with just 204.75 euros. This looks a little different than the other problems, but it's really the same. On the bottom of this, you would really just have 1, so I just didn't include that into the solution because you just have a 1 on the bottom of the fraction. So that would give me about 204.75 euros. We can also convert rates. For example, we can convert a speed in miles per hour to feet per second. So I can change the unit of anything that I'm dealing with. Because rates compare measures in 2 different units, we must multiply by 2 conversion factors to change both of the units. A student ran the 50-yard dash in 5.8 seconds. At what speed did the student run in miles per hour? Round your answer to the nearest tenth. So if we look at what we're starting with 50 yards every 5.8 seconds. I want to get to having miles per hour. So miles needs to be on the top at the end, and the hours needs to be on the bottom so that it's miles per hour. Per is a division. Miles divided by hours. So I have to be able to convert yards into miles, and I have to be able to convert seconds into hours. So let's set up a conversion factor that'll help us. Well, if I can know that 1 mile is 1,760 yards, what that'll do is convert into miles so far, because my yards will cancel with your yards, and you'll be left with miles per second, because those two are going to cancel out. All right, but I don't want miles per second, I want miles per hour. So I got to be able to convert this seconds into hours. Well, I also know that 3,600 seconds is 1 hour. 60 times 60 times 60. Right? 60 seconds in 1 hour, 60 seconds in 1 minute, 60 minutes in 1 hour would be 3,600 seconds. Okay? And what I'll have here is seconds here to cancel these seconds. So all I'd be left with on the bottom is hours, and on the top all I'd be left with is miles. So then I'd have miles per hour. So if you take a look at the canceling, yards will cancel yards, seconds will cancel seconds, and the only thing left is miles and hours. So now all you have to do is go across the top and multiply. 50 times 1 times 3,600 is 180,000 miles. And on the bottom, 5.8 times 1,760 times 1 is 10,208 hours. And then you want miles per 1 hour, so you just divide that, and you'd get about 17.6 miles per hour. So I just divided this 180,000 divided by 10,208, and I wind up with 17.6 miles per hour. All right. So another example of using your conversion factors to simplify your rates. He ran a sprint of 10 feet in 3.1 seconds. All right. So at what speed was the athlete running in miles per hour? Round to the nearest mile per hour. So what I see here is if it's 10 feet every 3.1 seconds, well then I have I got to convert into miles per hour. So something's got to get the top to be miles and the bottom to be hours. So what I first here started to do was convert the seconds into hours. So 60 seconds in 1 minute. That'll cancel the seconds and leave me with minutes. And then 60 minutes in 1 hour. You could have also used your 3,600 number from the previous example, 3,600 seconds in 1 hour. And it would have done the same thing as these two factors here. But I thought it might be a little easier to see what's going on. So the seconds will cancel the seconds, and then the minutes would cancel the minutes. And right now you'd be left with feet per hour, and then I have to get the feet into miles. Well, 1 mile is 5,280 feet. Okay? So these factors here we would have to give you a list of, or at least help you come up with the conversion factors for these. So what will happen at the end of this thing, seconds will cancel seconds, minutes will cancel minutes, and feet would cancel feet. So if you look at the units left, you would only have miles on the top and hours on the bottom. That's good. That's what you want, miles per hour. So if you go across the top, 360,000 miles, and on the bottom, 3.1 times 1 times 1 times 5,280 would give me 16,368 hours. Okay? And then if you just divide it, you'll get miles per hour, which is about 21.99 or 22 miles per hour. Okay? So it's all about setting up those conversion factors and then just using your calculator to help you go across the top, across the bottom, and then divide it. All right? There's section 2.6, my friends. I'll offer you a bonus opportunity. If you write your favorite color on the top of this 2.6 notes page and show it to me, I'll give you a bonus. All right? I'll see you next time. Peace.